Uh, Welcome to the session today. Nice seeing you here. I'm really excited to be at Hadoop Summit this year. I think the event is great. The venue is great. Sessions are really good. And the best thing that you can see is actually the energy you can feel around big data. It's clear that big data is here. It's here to stay. And a lot of people are seeing potential value in big data. Now, for a typical enterprise, big data is a big opportunity, but it's also a challenge. And the challenge can come from how do I integrate my existing IT investments with this new emerging technology. My name is Dražen, and in the next 40 minutes or so, I'm going to talk about Microsoft solutions that can help you seize the opportunity of big data by deeply integrating Hadoop with your relational data warehouses. My colleague Nicola will give you a short demo, walkthrough of what's the first-hand experience when you're using our products. Both of us are from the HD Insight development team, and we're working on some of the products that we'll show here today. Let's start. So what I would like you to take away from this session today basically comes down to these three things. I would like to say that Hadoop enables new insights. It's great, but it can bring with itself some challenges. It's not a free ride. Microsoft deeply integrates Hadoop with your data warehouse. And third, Microsoft uniquely offers solutions across on-premise and cloud. So basically, maybe we should just do a quick poll. So how many of you have already done things with Hadoop? Okay, a lot. How many of you have it in production? Also a lot. Nice. So how many of you have data warehouses? Cool. This is the right audience. So basically, in the session today, I will start with some high-level concepts, briefly talk about what we see as a way forward within the modern data architecture. We've all been hearing about these couple of days. Then I'm going to focus a little bit more on the appliance arena and basically the products we're offering as analytical appliances. And in the second half of the presentation, I'm going to go more technical, and then we're going to talk about how it actually works, how the appliance actually works, and what are we offering as the product. I encourage you to have a Q&A session at the end and basically go through your questions. We'll try to leave some time for that. So I would like to first introduce the modern data warehouse. So that's very part of what we've been hearing here as modern data architecture. You can think of this as the next step that comes after a traditional data warehouse. And basically, I'd like to start the story with a couple of use cases. I'm sure you've heard a lot of use cases and scenarios that people are showing all over the sessions here at this event. So I'll just briefly say that we're talking about similar scenarios. So for example, City of Barcelona wanted to get better insights into their government efficiency. And how they would do that, they would take their relational data sources, the data that they've been collecting in those systems, and then trying to correlate them with publicly available sources, such as social media data, GPS data, weblogs. And in order to do that, they needed a solution that integrates all kinds of data they could collect and basically provide insights on top of all the data types. Similarly, FusionX, a provider of BI solutions, wanted to help its customer, a building management firm, reduce energy consumption by 20%. And in order to do so, there are various signals being emitted from devices, different types of equipment that the company used. So they wanted to really be able to analyze all this data efficiently and get some insights from it. And finally, Virginia Tech basically wanted to make breakthroughs in medical and pharmaceutical research by doing DNA sequencing. For doing this, they turned to Hadoop in the cloud as the basic data processing architecture to crunch the enormous amounts of data they had to analyze. So what I would like to underline with this slide is that these are not your common data warehousing use cases. And that's why we're having this talk today. So what a traditional data warehouse is, I'm sure you all know since you all have data warehouses. It's a database designed to be used for analysis of data. It's meant to be the single source of truth for the enterprise. And basically, as data gets extracted, transformed, and loaded into the data warehouse, it's actually provisioned by IT. So when you access the data through BI tools, you're actually accessing data that's been provided by the IT. It's been cleansed. It's accurate, which is great. But what's the problem? Well, the problem is that we are reaching a tipping point in data warehouses. And back in 2012, Gartner characterized this as the most significant tipping point ever in data warehousing area. Why is that so? Basically, there are several trends that are making life really difficult for traditional data warehouses. First of all, we have increasing data volumes. We have many analysts saying data will increase 10 times over the next 5 years. And we're seeing initial phases of the trend already, which makes traditional data warehouses really at a challenge to keep up with this. Then we have requests from customers for near real-time insight. They're no longer ready to wait minutes to hours to get answers to their queries. They want to do it faster. Then, as a third factor, we have new data sources and types. It's no longer OLTP data coming from ERP, CRM, etc. It's also new types of data that we all heard about coming from devices, web, sensors, and it's data of all types, structured, non-structured, or semi-structured. And finally, we have cloud-born data. No longer is all data being born on-prem. A lot of it is being born in the cloud, whether it's from your IT enterprise infrastructure in the cloud or something else, it can be born there. Thus, these four factors are effectively breaking the traditional data warehouse. They are forcing us to change the concept. And what we're offering as a solution is the modern data warehouse. You can think of this as a modern data architecture for data warehousing. And what a modern data warehouse should be able to do, it has to be able to handle all types of data. So regardless of whether it's structured, semi-structured, or unstructured. But then it also needs to provide processing capabilities for all of the data, regardless of whether it's analytics run on top of the data or streaming or something else. It needs to be able to cope with all of these processing types. Then it needs to offer data enrichment in terms of extract, transform, and load processes, but also some capabilities for data quality and master data management. But finally, it has, as a major factor, it has to provide a single query model. Basically abstract your insight into the data from the data itself. And then basically you would be able to use this single query model regardless of the type of the underlying data. And then we should be able to plug in all types of BI tools like self-service BI, tools for collaboration coming from mobile apps that are used for BI, or predictive analytics. So basically, this is a logical, layered schema of what a modern data warehouse should be. And basically, what I would like to focus in this section of the presentation is that Microsoft offers freedom of deployment options and hybrid solutions that can basically help you get to the modern data warehouse. And we have three major pillars: box software on-premise, appliances, and cloud. In box software, we have SQL Server, which is one of the most popular database management systems used for data warehousing, and it's constantly being improved by new features like in-memory column store technology that makes huge performance gains for data warehousing queries. It really gets queries that used to last for minutes into sub-second responses. Then we have SQL Server Fast Track, which is basically a reference architecture. We're partnering with companies to provide recommendations for both hardware and software optimal configurations that could let you run SQL Server still SMP, but at an optimum configuration to achieve best possible data warehousing, query performance, still in a cost-effective way. And finally, for Hadoop, we are partnering with Hortonworks, and thus Hortonworks Data Platform, or HDP, is the Hadoop solution for the Windows platform. As part of this effort, Microsoft is also contributing to Hadoop, and we are contributing to open source some of our knowledge and experience in things like Stinger and Hive, where we're using basically knowledge in SQL databases that we had for many years. In appliances, we have the Parallel Data Warehouse, which is a massively parallel processing appliance for data warehousing. It offers up to 100 times performance increase compared to the box software. And recently, with the latest edition, we have added HD Insight cluster onto the appliance. So HD Insight is Microsoft's Hadoop solution. It is based on Hortonworks Data Platform. It has its core as HDP, and then it offers some additional features, and it's being deployed onto the appliance hardware and optimized. Thus, we're also offering an integration layer on top, both PDW, Parallel Data Warehouse, and HD Insight, that serves as the single query model that we've been talking about in the previous slide. And finally, in the cloud, we have SQL Server Enterprise Images for Azure VMs, Windows Azure VMs, that can get deployed as already optimized instances for data warehousing. And we have HD Insight for Windows Azure, which is our Hadoop cloud-based service. So the experience here is really, if you have some data, regardless of whether it's born in the cloud or on-premise, you load it first into Azure storage, where you can keep it very cost-effectively. Then, when you need to process the data in Hadoop, you can spin up an HD Insight cluster on demand in a matter of minutes. And you can do this either via the Azure UX portal, or you can do it programmatically. And then you can run your favorite Hadoop service, your favorite job, to process the data. Once you're done, you can drop the cluster, and you're no longer paying for the compute power because you're not using it. So it's very cost-effective in terms of how you store and how you process data in the cloud. To conclude the slide, so we have plenty to offer in the areas of data warehousing and big data across on-premise and cloud. And what is really important, we're focusing on providing features that really seamlessly connect box and appliance and cloud, and thus offer you very interesting hybrid solutions. Like, for example, having hot data on-premise. Once the data grows, it becomes old, you can move it to the cloud, where you can also process it like with your daily or weekly queries and jobs. And on-premise, you still have the top-notch performance that an appliance would provide you. So that makes very interesting scenarios to consider. So basically, in the next section, we're going to focus more on the appliance, the middle pillar here on the last slide. And I would like to introduce Microsoft Parallel Data Warehouse version 2 appliance update 1. It's the latest release, and it's really a modern warehousing appliance, a turnkey solution that consists of both PDW and HD Insight. Thus, you can think of it as enterprise-ready big data, where a relational and a non-relational store are installed on the same appliance, on the same hardware, side by side. And basically, there is integrated querying provided with split query functionality on the fly for both stores through a very popular T-SQL language commonly used by the millions of SQL Server users out there. And it features HD Insight, which is our enterprise-ready Hadoop solution. then you can also think about it as next generation performance at scale, which means that the relational massively parallel processing engine uses column store technology, which actually gives up to 100 times performance improvement and up to 15 times compression ratio for the column store data compared to row store. The system also easily scales out, and it keeps performance at scale. So as you add hardware, it can very easily grow and also keep performance at scale. And finally, the system is engineered for optimal value, which we would like to point out that it has industry's lowest data warehousing price per terabyte for the relational part of the storage. And it achieves this through usage of Windows Server storage spaces as a replacement for expensive SAN storage, and also through very high compression ratios achieved for column store data. And it provides value through a single appliance solution where you have both data stores integrated and features on top that actually helps you avoid doing this integration effort yourself. And finally, it also offers value through flexible hardware options. There are 3 vendors of hardware that we cooperate with, so you are able to choose the option that most fits your needs and avoid hardware lock-in in the future. So I would like to say something of HD Insight as our enterprise-ready Hadoop, a list of features. So basically, it is 100% Apache Hadoop compatible since it has HDP in its core. The Hadoop on the appliance is resilient to any single hardware failure, which means we have introduced additional fault tolerance into it on top of what Hadoop already provides with block replication and job resiliency. And it's tuned for the appliance hardware to provide high performance. Then it's a secured cluster that performs end-user authentication. And in terms of management, it can be managed through centralized appliance management tools and also System Center. So if you're using System Center to manage stuff in your corporation, you can also plug this into System Center and monitor it and manage it from there. And finally, it gives accessible insights for everyone using Microsoft BI tools, but also third-party tools that can speak T-SQL, thanks to the integration layer on top of both stores. In terms of scale-out, we have basic units of scale, which we call scale units, not a very creative name, that basically consist of groups of nodes with dedicated CPU, memory, and storage. And then in a system like this, you would start small by having a single scale unit of PDW. Then, as data grows, or you start needing non-relational data, then you could add more scale units of either PDW or HD Insight within the first rack. And then, of course, the same story would continue in additional racks, spanning up to 6 petabytes. And the system keeps near linear scale as it adds more hardware. And of course, it's also capable of handling concurrency in terms of having multiple users hit it with queries or jobs for the HD Insight part. PolyBase is the feature we use for connecting islands of data. So it's the bridge that connects different types of data. And basically, it allows users to use a single T-SQL-based query model for both PDW and Hadoop. It has a rich set of language features and doesn't force you to do complex ETL prior to actually running these queries. And it enhances performance by using the massively parallel processing engine and its compute power. But it also makes the appliance an open and collaborative platform. What this means is that it also offers integration with external Hadoop clusters from Cloudera or Hortonworks. There's a set of supported options. And it also allows you to move data to Windows storage, Azure storage, and back to enable these hybrid scenarios. So in terms of PolyBase, the most interesting use cases could be high-performance queries against Hadoop data, where actually you map database objects onto Hadoop data, and then when you submit queries, the data gets either copied over or there's some compute pushdown into Hadoop. Or archiving warehouse data to Hadoop. If you want to have an active archive, then you can move the data into Hadoop, but it's still one query away. It's not like you put it onto some server where you would have difficulties of bringing it back. You can actually use the same database objects you use to export the data to bring them back in as you need them. Then also exporting relational data to Hadoop, where you can use Hadoop for sharing data among different users, and importing Hadoop data into the data warehouse. So this is like a variant of the first use case where you would prefetch the data, transform it into data warehouse tables, and then you would use the data warehouse as a really fast ad hoc querying system. It's even greater performance than the first use case. So now let's start going deeper and basically see how the system works, starting with the hardware architecture. So here we have a single rack of components. There's some common infrastructure like the networking and power supply, and it's all redundant, both the power supply and networking. And then we have scale units. This is the basic scale of a PDW system. And basically here we have two scale units of HD Insight, something that is a starting or base scale unit and an additional active scale unit. So we have here processing nodes and storage in all of these scale units. And as we go into the second cluster, the story continues. Basically, we just add more scale units, and thus we scale out. And in terms of the components that form a scale unit, we have in one of the reference architectures, we have 4 servers, 2 servers that are directly attached to storage, and 2 servers that are not directly attached to storage. So these are typically, and in our case, they are used for hosting master or coordinator services that actually run the cluster. And then these guys here are actually used for heavy data processing. They are directly attached to the data. Networks are double. Ethernet is used for external communication. Within the cluster, nodes actually use InfiniBand connections to do the heavy lifting of data and transfer. In terms of the software architecture, this is what a single base scale unit is. Master node and its spare server connected with a Windows failover cluster. So basically, as we are virtualized, we have 3 VMs placed on the master node, a secure node, a head node, and a management node. If any of these monitored services on these nodes fail, we basically activate the failover cluster and move the VMs to the spare server. So basically bring them back online, and the cluster continues to work. Then, of course, on the worker nodes, we have 2 data nodes per each server. They split the physical resources equally. And in terms of the services placed on these VMs, we have, on the secure node, we have IIS server that has 2 websites, the gateway, the secure gateway, which actually performs authentication. It acts as a proxy for the cluster. And we have a developer dashboard, about which I'll say something a little bit later. And then we have on the head node, the usual Hadoop services you're used to seeing, like name node, job tracker, Hive, WebHCat, Uzi. And then on the management node, we have services we use internally to monitor and manage the cluster and make it run. So things like Active Directory, SQL Server instance housing, Hive and Uzi Metastore, but also storing the metrics collected through Ambari and the Ambari server itself, which fetches this data that is being used for monitoring in appliance monitoring tools. on worker nodes. Of course, data nodes and task tracker that do the heavy processing. Then how would I manage and monitor this system? So this is the admin story. In this case, we have centralized and consistent monitoring and management tools for the entire appliance. So you use the same tools to monitor and manage both the relational and the non-relational part. From there, you can manage things like firewall and network configuration, setting up user accounts, monitoring the health of hardware and services, jobs, etc. So a couple of screenshots of these tools here. We also have a system center integration, downloadable management packs that you use to extend the SCOM. So basically, you could manage both PDW and HD Insight from this tool. It gives very nice topology schemas of the cluster with statuses of services and nodes, and basically aggregational type of graphs where you can see usage of your storage, job histories, etc. And finally, we are sure we haven't implemented abstractions on top of all the tuning knobs you would like to change in Hadoop. So that's why we have a white list of configurations that are safe to change. And we have remote desktop connection for admins to every node in the cluster. So basically, admins could go in and manage the cluster from native Hadoop configuration tools. In terms of loading the data and curating it, this is the development process. So basically, it really depends on the use case, how you load data. For example, for high bandwidth, high data volume loads, you could pull in data in parallel from corporate network shares. If you had multiple client applications that would push trickle loads into the system, then you would be hitting the web HDFS endpoint from those applications. In either case, you don't have to do any complex ETL like Hadoop is meant to be used. Basically, you just load files. And in high bandwidth loads, you could actually achieve InfiniBand throughputs if you connected the appliance to the outer network via an InfiniBand. You can saturate that pretty quickly. In terms of data exploration, we have something we call Developer Dashboard. It's a web-based application that offers links to some commonly used Hadoop UIs like the name node web interface or job tracker web interface. It also provides some additional functionality for uploading data samples, uploading UDF jars, for example, SERDES for Hive, and then quickly running jobs, viewing some job history of the jobs you have submitted through this tool previously. And also it offers a Hive console, which features an object explorer. There's a query editor with some syntax highlighting, and there's query history that allows you to go back into your query history, like copy a query, edit it a little bit, and submit a new query. So this is some of the functionality that you would expect from like database servers is in this console, and it really needs to allow you quick experimentation with the data before you're ready to operationalize. Once you're ready to access the cluster programmatically from your apps, you can then hit Hadoop REST APIs, such as WebHCat and Oozie. And finally, we are going to provide a Microsoft.NET SDK on top of this REST API. So for a .NET developer, you could actually download a NuGet package. You can start using it in your project, and then you have a really nice way to abstract things and basically submit jobs without actually putting together parameters for WebHCat one by one. And then the next slide, basically querying all data. So we mentioned the single query model. I want to go a little bit further on it here. PolyBase makes querying really straightforward. It creates external tables, maps those tables onto Hadoop data. When you query the external table, it actually fetches data from Hadoop. It also does cost-based optimization based on statistics. And it can do predicate pushdown based on those statistics. So this split querying is really what it is all about here, because it lets you use your favorite tools like SQL Server developer tools that you would use with SQL Server anyway. It also allows plugging in any BI tool from Microsoft, but also third parties through the T-SQL language, supported by the PDW. So you can create reports in Excel, such as this one, or maybe some visualization in very cool Power BI tools like Power Map shown here with absolutely awesome visualization of geographical data. So basically, as we prepare for the demo, I'll just quickly show you the PolyBase syntax. And basically, here is how you would create an external data source, like either HD Insight cluster on the appliance or an external Hadoop cluster. Then you provide a file format definition, basically how do I interpret those files that I want to use in my external table. Then we create an external table, in this case clickstream. We provide a schema for it, and then we reference a source and file format. And then when we do selection from the table, we're actually either pulling in data from Hadoop or pushing down this predicate here, but the data is directly queried from Hadoop. And basically, people that haven't created the external table do not have to care where the external table is, how it has been created, and so on. The same goes for exporting data from PDW into Hadoop. We can actually select from one of the dimension tables or fact tables or from your data warehouse and do a create external table as select, where basically data gets exported into Hadoop. Now, what is really nice here is that if I created this table and I gave you its name, you can query it without actually knowing what this location is or what source is or what file format is used. So this is really nice for like having people that know how to work with Hadoop and having people that do not have to know how to work with Hadoop. And basically, both of those guys have easier jobs with these solutions, but the second group doesn't even have to know that the data is actually in Hadoop. And then basically, if we go through the PolyBase query lifecycle, this is what we would do. Creation of data sources tables. There's DDL that gets executed in PDW. It creates objects of this metadata in its catalog. Then we can create statistics, at which point the system would sample the data from Hadoop. It will do aggregation of the statistics and save it for queries in future. And then basically when we do selection, the query optimizer would say, I have a predicate here, I have statistics on this table, so let's see. What is a better deal here? Do I push down computation into Hadoop? Is the file large enough? Is it going to get much hits for this predicate, et cetera, et cetera? And then if we, for example, conclude that it is the case, then we push down the predicate into a MapReduce job. It spins on the cluster. And then once it's done, we pull the data back through the front door and provide it to the user. So at this point, I would like to ask Nikola to do the short demo before we go to conclusions.
Thank you.
Can we switch?
Hello, everyone. My name is Nikola Vujic. I work in a Hadoop appliance project at Microsoft, and here we're going to go through a short, quick demo. Okay. So here we're going to go through a quick demo to see how we can leverage integration of parallel data warehouse with Hadoop, and how we can derive some business insights from that integration. Before we start, I would like to let you know that this is a recorded demo for the presentation purposes, so this is not a live system. So let's pretend we are sales managers in a retailer company operating across the globe. So we have all data about our transactions, online transactions in a data warehouse. So here we have our database and tables. Here we have sales transactions, and all other business dimensions are in the other tables. To make this easier, we can create in Power Pivot a model for the database. So all tables and the relations are here, and this let us create a dashboard in Power View where we can easily slice and dice through through all dimensions. So what we want to do here is we want to, for example, we want to analyze sales amount per geographic location. And in this model, we are missing that information. So all transactions are done online on the web servers, and web servers are catching the geographic location, and it's dumping whole info in Hadoop, for example. So that's the use case. And if we go to Hadoop UI and browse HDFS, we can find that information in an HDFS file. So here we have all location info. So how we can work with that? First thing we can switch to Visual Studio, where we can create T-SQL queries. First we have to do is to create external table, as Dražen explained, the syntax. So we create external table. It's enough to pass the location to the HDFS file, and we need to pass a proper format options in order to know how to parse a file. So when we run it, we will immediately observe that in the list of external tables, our location info table appears. And from now on, we work with that table as with any other internal table in the data warehouse. So now we can go and select star from the table. When we do that, so all the content of the table is going to appear here in the table format. And we can do other queries like filtering all rows with a name like John, and we can quickly get results of that as well. For the more detailed and more complex analysis, we can join this table with any other table we have. Here we have an inner join based on the email address of the person who submitted the transaction. And we want to select the top cities which are contributing the most to our sales amount. And when we run this query, this internal join is going to happen. So from the user point of view, we don't know anything about this table. We don't know that there is a bunch of traffic going on between PDW region and Hadoop. So under the hood, PolyBase is doing all traffic, but we don't have to know anything about that in order to run this query. So very easily, we can get, for example, here that in this example, Berlin is contributing the most to our sales, and we can get information for the other locations. So this is not all. We can, once we run these queries, if we want to preserve these queries and the result of the queries so that other colleagues in the company can consume that later, we can simply push that back to Hadoop, and we can create these external tables. Again, just we need a location in the beginning, and then when we execute the query, whole execution result is going to be in Hadoop. So if we go back to HDFS folder, we are going to see that this sales by region export folder appears. So result of the query is there, and we can easily just read it when we need. So suitable for any kind of weekly, monthly reports, something that we run once and read many times. Then we can extend, alter our Power Pivot model and add location info table and the relation with the other tables, and this will let us create also new dashboards in the Power View where we can slice and dice through geographic location info, and that would be all from this demo. I hope you enjoyed the short demo we prepared.
Thanks. So can we go back to the slide deck? So I just have key takeaways again. I would like to take these away. Hadoop enables new insights, but also brings new challenges. And hopefully I have shown that Microsoft deeply integrates Hadoop with your data warehouse, and Microsoft uniquely offers solutions across on-premise and cloud. So think about it, and basically we can do a short Q&A session now.
We actually don't have very much time. The next session starts in 9 minutes, so we have to get ready for the next one.
Okay.
So maybe one question.
Yeah.
So when the query is fired, does the user need to know that the query
No. The user doesn't have to know that. Basically, the query will provide the same functionality. What can happen is, depending on the form of the query, it can perform differently depending on whether you can push down predicates into Hadoop. But it also depends on the stats of the table, external table. But I guess that's what you would expect from any table, that depending on its dimension and the content, query can basically perform differently. But the functionality is always the same. So we'll be here in the next couple of minutes if you want to ask more questions, or outside of the room. So feel free to reach out to us. Thank you very much for coming.
Thank you.